Hello, my name is Yamel Guerra. I did my executive summary on photo-assisted CO2 conversion to fuel. This article was written by Sonia Ramiro Buenamañana. She has a bachelor's in chemistry, she's a master's in organic chemistry, and a postdoctorate researcher. The second author is Hermelindo Garcia. He's a professor in the University of Valencia, and he studies catalysts and nanoparticles. He has 700 papers written and 35 patents. The article explores the use of photoassisted carbon dioxide conversion to fuels that focus on materials that reduce CO2 emissions. The article goes through the experiments completed to show different methods used. The article explores ultraviolet transformations, and which the UV light excites molecules to create energy. The next process described was the photocatalyst, which uses materials to convert photons into chemical energy. The last process studied in the article was the photochemical process, where direct CO2 is excited. And with all of these procedures, titanium dioxide was used as the constant to see how these reactions created electricity. All of these would help global warming and climate change by reducing CO2 emissions. So that is why this research is important. The first test, as mentioned, was a deep ultraviolet test. This is a photochemical procedure. No photocatalysts were needed. This test would transform CO2 into carbon monoxide and oxygen. It showed that it absorbed photons and transformed to hydrocarbons. Within this same test, the article tests methane and transforms it into CO2, and it shows that it would absorb photons as well. Results were that CO2 was reduced, which is also called artificial photosynthesis. The second procedure or test explored in the article is photocatalyst test. This is where UV or visible light are used, and for this particular test described in the article, titanium dioxide was used. They mention a procedure called metal doping procedure. They also test amorphication procedure, and the results after these tests showed that it would enhance the energy given from titanium dioxide. Metals produced visible light, and they went through photocatalyst reaction when you would combine the metals. The last procedure was the nanoparticles on graphene. Graphene is introduced with titanium dioxide. This photocatalyst activity, the photocatalyst activity of titanium dioxide increased by 20%. And graphene can also aid in the separation of charges from semiconductors, and it shows that graphene could be used as a semiconductor. And defective graphene combined with ultraviolet light would produce artificial photosynthesis. The results were that CO2 was reduced with this procedure as well. The results were that quantum efficiencies on solar light were greater using photo-assisted procedures by 13% and 0.1% with artificial photosynthesis. In conclusion, the photochemical procedure reduced CO2, and the photocatalyst procedure reduced CO2. More research has to be explored in these procedures, So renewable energy around the world could be more efficient and more economical for everyone. Thank you.